an infinite number of mathematicians enter the bar, and the first mathematician orders one shot. The second orders half a shot. The third mathematician orders quarter of a shot, and the bartender pours them 2 shots and says, guys, you have to know your limit. It's so nice to be here in a cozy little room. I like giving talks in small rooms. Antwerp is an amazing city. I'm blown away. So happy to be here and thankful to be invited. Let's move on to talk a little bit about infinity, which is I hinted on with the opening joke. So infinity is something that we as humans have trouble dealing with because we have evolved. We are all here because our ancestors, our lineage, have survived by fighting scarcity. So we are really well equipped to deal with scarcity, with constraints, with limits. And then when we are presented with the concept of infinity, we start losing it. And there are some illustrations that can help. For example, I don't know how many of you have heard of the Hilbert paradox, the Grand Hotel, which is something that one of my favorite living scientists, Lawrence Krauss, likes to talk about. But imagine a hotel, Grand Hotel with infinite number of rooms. All rooms are occupied. And here comes a new guest, and he wants to book the room. No problem. So the receptionist will move the person from room 1 to room 2, from room 2 to room 3, and so on. There is no limits on rooms, so it's easy to accommodate. Not only that, but even if infinite number of guests enter the reception, they could all be accommodated. So this is something that is counterintuitive to us. And Lawrence Krauss likes to say, anytime we start dabbling in infinity, things start getting ridiculous and then slowly turn into absurd. So we just cannot wrap our head around. And you know, when we talk about quantum mechanics, Richard Feynman, one of the most brilliant scientists, he said we can certainly do quantum mechanics, but we cannot understand it. He was the first one to say, I just cannot understand what it is. So the reason I'm mentioning this is now, today in year 2025, as my previous colleague in his talk mentioned, we are all about AI and the AI revolution, and it's all dealing with these limitless situations. So let's move on to another thing I want to talk about, which is a little less abstract. It's information. Now, I'm a scientist by education and by training, and more specifically, I'm a biologist, and my discipline is numerical ecology. That, working in that field led me to software and to simulate large systems, large data. The information is something that we all, people in software, deal with daily. And the first thing I want to mention, how many people here have actually read this book? No, excellent. Yeah, I stumbled upon that book when I was doing my master's degree, and it really made a huge impact on me. It really attracted me to the concept of artificial intelligence. And if you haven't read it, it's a recommended read. So in here, again, we're talking about these counterintuitive concepts that we encounter when we start dealing with software, because I'll move on to the next book. How many people have read Gregory Bateson? Oh, nice, nice. This book was a life-changing book for me. Steps to an Ecology of Mind. So, we're talking a lot about information, minds, infinity, But at the same time, we are biological creatures. And again, I'm pointing to the fact that we are dealing with scarcity throughout our life. And so making this transition, now that we're encountering AI, we are working with it, it's a bizarre, at least in my experience, a little bit of a bizarre situation. Now, why do I want to talk about Gregory Bateson a little bit? Because he taught me some interesting concepts about information. Now, his definition of information is that information is any difference that makes a difference. In other words, if we have a uniform environment where there are no differences, then there is no information there. Information, according to Gregory Bateson, is dimensionless, does not have volume nor mass, no dimension, therefore it is limitless. And again, we are dealing with infinity. And infinity is something that we cannot grasp very easily. So in this talk, I'm going to talk a little bit about how do we approach this concept of infinity, limitless situations when developing software, when interacting with systems. My focus is mostly systems programming. And for systems programming, we still don't have a specific language. So you probably know where I'm going with this. This year has been introduced vibing. I don't know how many people tried vibing, vibe coding. If you have, okay. It's an interesting, they call it AI native situation, where basically similar to how we, let's say 15 or 10 years ago, started going cloud native. So we were moving from ClickOps, people who are administrators and operators, clicking around and configuring large systems, migrating to the cloud. There was a big upheaval back then, and somehow we made it through, and now cloud native is kind of mainstream. Pretty much everybody's doing it. The next wave that is now being proposed is AI native, which again, we are seeing a lot of pushback. People saying, no, it's never going to happen, impossible. We need human at the helm, etc. Now, I'll just relate my experiences. I'm a musician, and my band, we have so far released 13 albums. And so we're working hard and recording. I'm also a little bit of a producer, mixing, mastering, deciding on the visuals, naming our songs, etc. And so recently we started, the band members, we got together and we're like, okay, look, we have a lot of material. We have many, many songs and tracks. Why don't we look into creating the best of album? And then we can, once we have the best of album, we can maybe go and start promoting our music. And I said, sure, okay, how about I build an app, and we can have band members and maybe some of our fans can go there and, rate our songs, and then we create the leaderboard, and the top 10 songs would qualify to be our best of. And so I realized I don't have time to really build that app. So I said, why don't I try vibe coding? So I went to some of those vibing platforms, and I gave it the so-called zero-shot prompt, which means one big narrative saying, hey, I want to build this. And lo and behold, it built me a beautiful, responsive, reactive app that looked amazing. and it did absolutely everything I asked it to do. I was like, wow, I can't believe how this works. And it picked up so many hints. It's incredible. But then, and it even deployed. It was live. Everything in one fell swoop. Incredible. But then, when you have something that is not just a prototype or a trial balloon or a draft, then you get excited. So I log in and I started looking around and adding songs and albums. And then I realized, oh, I want to change this, I want to add that, I want to remove this. And then I was back and forth talking to this, Ken Beck calls it genie, the genie out of the bottle, that you can just rub the bottle and tell it your wish. And then, as I kept changing and adding, it was kind of working, and then suddenly it started deteriorating. Now, I don't know if this is your experience, but you can quickly paint yourself in a corner. I got to the point where it was just kind of spinning in circles. And it was like, oh man, I messed up. So then I spoke to some colleagues of mine and friends, and they're like, oh yeah, you have to go in and you have to maybe roll up your sleeves and start, fixing things and reading the code. And I'm like, well, then I could have done it from, scratch. Why do I need this if I have to intervene and start fixing things? So that to me is kind of what the limitation currently is of the vibe code. It works pretty good if we have a simple, zero shot. You articulate what you want, and you're not going to be making any changes. You're like, good. Maybe I should have stayed with the initial iteration, but it wasn't really functioning the way I liked it. But if that's not the case, I'm not convinced at this point that you can really build quality systems by just giving it natural language narrative. Also, I want to encourage you to interrupt me and raise your hand. Your comments or questions, issues. I'm not here to teach anything. I'm here actually to learn. So please interrupt me, no problem. And so we have this famous thing. Why did you write such a long function or such a long email? Because it was easy for me to write it. And then the question is, at what cost? And the cost is maintainability. And there's a famous anecdote, I think Mark Twain, or I don't know who really can be attributed to, but he apologized for writing a long letter because he didn't have time to write a shorter one. So this is another issue in software, and not related to AI, but in my experience, I've been doing this for over 30 years, and most of the time, if I look back, most of the time spent developing software is actually in the maintenance mode. And I don't know exactly what would be percentage, but it's definitely more than 50%, if not going higher, where I'm not writing any new code. I'm basically patching and maintaining and embellishing the existing code. And this is what we call refactoring. Now, refactoring can be a problem because it turns out if we're not doing it regularly or even while we are making changes, then we accumulate a so-called technical debt. And then this well-worn book, I will refactor that code later today, another hilarious joke you can tell yourself. All of these good-to-do things and wholesome things get pushed away on the back burner for later, and that later never comes, and then little by little we kind of find ourselves shooting ourselves in the foot. And I've been in some situations where we get to the point where, like, you know what, this is not maintainable. We need to rewrite from scratch. And that's an ugly defeat that never looks good on anyone. So it is an ongoing challenge with software code, the maintainability and the need to refactor. And indeed, the title of my talk here is The Future of Refactoring, how I see that may unfold. Because, you know, as the saying goes, the speed of typing or the speed of writing code is never a bottleneck. Now, for some reason, in some teams, some managers or people who are supervising or who are sponsoring, and they're a little bit mystified about, okay, what is this software? I don't get it. And then, for some reason, a lot of people tend to think that the productivity is actually writing code. And if we could speed that up, then we will be able to quicker go to the market. And then, of course, when we see AI being able to spit out reams and reams of code in seconds, then people who look at things that way get excited. Like, okay, well, now we have this spaceship we can launch and we can run into a stratosphere, but not being aware of this hidden cost, which is technical debt, maintainability, and then, of course, eventually hitting the wall and having to throw the towel in and say, okay, I admit the defeat, we need to rewrite this, and that's not good. So I pretty much assume that most people here, this resonates with you. You've been in similar situations. Yes, go ahead. Oh, I think somebody, no, okay. So one problem in software development that I've been encountering, and pretty much all of my colleagues, is ambiguity. So two or more people can see the same specification or the same request in a different way. Like this person on the left sees a vase and the other person sees two people. And this is something that we have to deal with because, you know, we could build, if we have a really good team, we could build a really solid product, but if it has been misinterpreted and it's built in a different, in not a correct direction, then it's a waste of time. And oftentimes, you know, we see that teams build something, and then when they put in front of the customer go, well, this is not it. This is not what we actually asked. So it's this game of broken telephones. And it's a real problem, right? Of course, it's even bigger problem if we're using AI genie or agent to be part of our team. And if, depending on how this agent interprets our narrative, we can have different outcomes. There's also something I want to quickly touch upon. This is called the VUCA world. I don't know if you've heard of the VUCA world, which is an acronym for volatility, uncertainty, complexity, and ambiguity. It's a deadly combination of these four factors. Basically, what it is I often like to say, well, none of us have a crystal ball. We like to fancy and imagine that we know what's going to happen, you know, next spring, and we are creating a roadmap. We are committing, making plans, and by such and such time, we're going to be unleashing or launching such and such product, etc. But as the saying goes, reality bats last, and you know, maybe some unpleasant surprises down the road. I'll give you one example. I was working on a few really big-ticket projects 5 years ago, more than 5 years ago, and we had big plans and big ambitions, and then March 2020 hit, and it all fell apart. Nobody could have predicted the pandemic. I mean, some people are talking about this, but this level of impact and this level of, you know, hitting the wall and crumbling down was devastating to some of us, to our business. And so it's not just that we cannot predict events in our daily lives and in the future. And then some people say, yeah, of course, but we can predict the trends, macro trends. But even that is volatile and uncertain. And so we have to acknowledge that, accept it, and then figure out how do we, in this unpredictable world, how do we move forward? How do we pick our battles? When do we know when to cut our losses? Such things, the business acumen. One way to do this, I don't know if anyone here heard of permaculture by succession. This is something that emerges. Now, I'm a big, I forgot to mention, I'm a big proponent of extreme programming, XP. This is something that emerged, I think 30 years ago. I think Kent Beck can be blamed for introducing that. And then, it became more and more prominent, but it never really became mainstream because it requires a certain level of discipline. However, I would say that now in the age of AI, it is a good tool to have in a toolbox. Let me explain what permaculture by succession is. Let's say we have a goal, somebody gives us the goal. Here's a barren terrain, some desert. And I want you and your team to populate this desert by planting forest trees. It's a very noble and lofty goal. And now we are, we could have a zero-shot approach, and we could order huge Douglas fir trees and bring them in via helicopters, I don't know, and then try and plant them. But that very slim chances that will work. The trees will die out. Why? Because the conditions are harsh. They're hostile. It's really extreme temperatures. We gotta have a different approach. So, knowing that we cannot make a giant leap and go from desert to the lush forest in one step, we have no recourse but to kind of lay down our arms and say, look, yes, I can envision a very nice and sophisticated design, but I have no way of getting from here to that stage unless we take some intermediate steps, which means we will be proposing designs that are throwaway, that are kind of ephemeral. They're just for the time being. We know that this design is not going to stick, and we are okay with that. We are not upset about it. We're not making a pet out of our design and cherish it and nourish it. It's a disposable rung on the ladder of climbing to our destination. So the first thing we would do is our initial design, we will be planting some fast-growing grass. That grass can thrive in harsh conditions, can survive. So what's the point in doing that? But it softens a little bit the harshness of the environment. We have some vegetation, and it may help create some soil instead of just sand. Then we introduce, in our next step, so-called manzanita shrubs. These shrubs are very sturdy, very hardy. They can thrive in dry and extreme conditions, but because there's some soil provided by the grass, it can sustain itself. So now, we have moved into the next. We are not done, right? And we know that this is not where we want to stop, and this is not what we want to deliver. But the intermediate step, we're okay with that because now it creates a more hospitable environment for us to make the next step. So we are going step by step. After that, we can add larger bushes. They create some shade. They can soften again the harsh microclimate, etc., etc. And finally, we can plant the Douglas fir trees, and they can survive and thrive. So this is kind of the extreme programming approach, where we are going in deliberately smaller steps, even though we know what we want at the end, but we know we cannot get from here to there. We are not creating roadmaps per se. It's more like C-chart. So, roadmap, okay, you have the road, you paved, and I want to go from Antwerp to Amsterdam, and here's the map, and I can just drive and get there. I can calculate how long will it take me, how much gas do I need. That's all predictable. That's not VUCA. But when we're sailing, I don't know how many people sail here, and we know the destination, but we can never chart that journey in a straight line, because we know the winds are unpredictable. Sometimes we'll have to make a turn and go the opposite way just to catch another wind. So our journey will be a bit meandering before we hit the actual destination. Now is the demo time, but let's see if you have any questions before we go into a little bit of a demo. Okie doke. So for the demo, I am going to introduce something that I kind of gradually came up to my mind as I was working with AI. And of course, AI would be, the way I described it earlier, the vibing, would be this attempt to, hey, plant this huge forest trees in the desert. And then AI will be going and doing all kinds of work behind the scenes, and usually typically deliver something that's not sustainable. So test-driven navigation. This is, of course, inspired by my practice in extreme programming, of which one of the main components is test-driven development, or TDD. How many people are familiar with test-driven development? Oh, great, fantastic. Yeah, that's nice. So this is a slant on test-driven development, inspired by it. Also, I want to mention at this juncture that one inspiration for this talk was from the person I work with who became my mentor, Andrei Kaminsky. Very good AI visionary. I like his ideas on where things are going. And I ran this by him, and he's like, yeah, he thinks that's promising or could move in the right direction. All right, so I'm going to read this to you, and I apologize. I know that reading the slides is kind of lame, but just so that we set the stage. I am giving the prompt to the genie or AI agent, whatever we want to call it, and I'll read. It's a bit of a larger narrative because I want to set the stage before we start working. So here's what I'm telling the genie. I'm like, I would like to teach you my new approach to software development. I call it test-driven navigation, TDN. I plan to use TDN as a guiding principle when I interact with you while we are building a software application. Then next thing I say is, instead of giving you a prompt and asking you to implement my intentions by interpreting a possibly vague specification expressed as an English narrative, I prefer to give you a failing test. That test will, in this case, be implemented using JavaScript. I'm using JavaScript for simplicity so that we have the least possible amount of infrastructure. And I'm using testing framework Jest for unit testing. I will hand code the failing test and will then ask you to make that test pass. In this arrangement, I am the navigator and you are the driver. So I'm setting the roles. I propose the direction, where to go, and you drive the implementation. I ask you to do something in code and you figure out how to do it. The onus will be on you to figure out how to write implementation code that will satisfy the expectation in the failing test. The idea is to see quick feedback. So you're allowed to use Canback's fake it till you make it trick, even including the cheat where the code you implement initially returns a hard-coded value to make the failing test pass. We prefer to grow the solution incrementally and iteratively, moving from a primitive obsession toward more appropriate abstractions that will articulate the domain we're trying to automate. Now, question, why am I asking that? Why am I allowing it to cheat and return hard-coded values? Maybe it will be clearer when we do the demo. But chime in, please, if you have any ideas. And I'm adding, also, as we keep moving and growing the app, the onus will be on you to keep refactoring your code to make writing the next failing test easy. This is one problem that some people encounter, is that you start with test-driven development and it's writing tests and all that, and eventually it gets to a point where the next test becomes a problem for the genie to make it pass. And then we hit the wall again. So I'm warning you to say, look, you need to keep refactoring the code, because when I throw the next test at you, you shouldn't be like, oh, I don't know how to make it pass. Then I have to roll up my sleeves and I have to start coding, and that's not the goal here. In case you write implementation code that does not cover the processing logic, as well as the deviation from the processing logic, it will be your responsibility to write additional tests to cover the gaps. Okay, this is a long process, sorry, but I have to. Anytime you make a change, I want you to tell me if you're adding new code to the existing file, or modifying the code in the existing file, or creating a new file. If you're creating a new file, I want you to tell me in which folder is that new file stored. Why am I saying this? Because sometimes we hear that people say, okay, I go and talk to the AI, and then the AI goes away and creates like truckload of code, and I have no idea where that code is and what is this code doing. And so I am very reluctant to deploy it because I have no idea what's going to happen. So I want to be a little in a supervisory position and kind of understand where is this genie going. I want you to keep test files in the root folder and app files in the /app folder. If you need to write a new test or refactor existing tests, abstain from mocking. Mocking is another evil thing that AI can really go into downward spiral. So I'm allergic to mocking. Instead, always use values to represent behavior. Values are, to me, incredibly powerful because, as some of you know, value is interchangeable with function. So they're one and the same thing. Unless explicitly specified, strive to implement business policy rules in a core competence layer, which runs in main memory and is unaware of outside dependencies. Why am I asking you to do that? Any idea? I want to avoid adding accidental complexity. In my experience, accidental complexity is a big problem in software. And it tends to happen when we mix the business policy rules with the elaborate, sophisticated infrastructure. And then before you know it, it becomes an entangled mess. It's very difficult to reason about, technical debt, and then downward spiral. So we like to segregate the outside world, the dependencies on, how is the information coming into the system, where is the information going out of the system, and keep the logic, the reasoning about how are we transforming values inside what we call the core competence layer, which is pure abstraction, not aware of any keyboards or screens or databases or networks, anything like that. That way, it becomes much easier to test it. And also those tests will run will exercise the code, and because the code is running in main memory, everything is super fast, so we can have thousands of tests in no time. So that's, kind of extreme programming approach. Okay, so I'm further saying TDN is about eliciting the precise rules and behaviors from the domain. In this process, we will be iteratively discovering the complete and accurate specification together. When we detect duplication, it's a signal from the domain saying, hey, this is a distinct concept that needs its own home and rules. We are both explorers in a shared, partially mapped domain. A failing test is not just a task, it's a question about the domain. So we're kind of shifting the focus from just the implementation and deep in the weeds, more towards discovering the domain. What are we automating here? What's the actual, in reality, what's going on here? And finally, keep your responses terse. No need to explain your thinking to me. Just produce the code needed to make the test pass. I'm saying this because oftentimes the genies give me like the whole novel about what are they thinking, I'm not interested in that. Maybe I should, I don't know. And I'm saying, does this make sense to you? Okay, any questions on this? Did I manage to confuse you? Okay, let's see. So for this exercise, I'll be using very bare bones arrangement, just so that we are clear on what's going on. So just in VS Code as an editor, I'll be using a terminal for running tests. And then I have this, because the time is limited, usually when I'm doing workshops, I'll be doing hand coding and everything. But here I prepared the canned tests and things so that I can just copy and paste to save time. I hope you don't mind. And I chose Claude. We can choose any of these. There's millions of these. But, so I'm going to give him the prompt, and he's going to think about it. I'm anthropomorphizing, calling the genie he or she, but should be probably calling it it. So it says, yeah, I understand, ready for the first failing test. We won't dwell too much on, so let me add the first failing test. So I'm going to create a test file. I'm going to call it day or night utility test. Oops, sorry. Wrong button. So what is this test doing? Do I need to enlarge, maybe? Is this good? Yeah, okay. So I'm not telling the genie anything about the business domain. I want these things to be discovered. So the genie is unaware of what are we even trying to do here. Just give it a test. And the test is describing the question, when is it daylight? And it says daylight denotes hours between 6 a.m. and 6 p.m. or 18 hours. And then inside the test, we have a simple situation where we have expected value would be daylight. The actual value will happen when this test agitates the system. And then the value will be returned, and then the assertion, or the expectation, will be conducted, and then the test will tell us, did it pass or fail? Now, of course, if I do npm test. Let's see if I can. It fails because it says, hey, you asked me to agitate or run some system, but it's not there yet. You say it's required, but I don't see it. So I have to add it. And I'm going to create this function in the app folder. I'm going to call it day or night utility. And here I've created a simple function called what part of day. And in this function, I'm just returning a hard-coded value. I'm saying no idea. Why am I doing that? Because it's very important to see the test fail. I always like to start from a broken system. And by broken, I mean I broke it. I know why I broke it. And that's important to me because then, when I know we're starting from a broken system, the tests are screaming, when I make a change and make it pass, then I know for sure that I'm A, asserting the right thing, and B, this will never happen. The breakage will never happen again, because if something later changes, the test will complain. So if we run again, it fails, but now it says, okay, look, I was expecting daylight, but I received no idea. So now, let me present this challenge to Monsieur Claude. Let's see what Claude has to say. Okay, well, Claude says, all right, I see how to make this pass. And he's simply proposing that we add daylight, return daylight. Now it passes, okay, fantastic. Well, we're cheating, so like, what's up with that? Like, how is this useful? But then, I'm gonna immediately follow up with a new test. And in this test, I'm going to ask the flip question, when is it nighttime? So expect nighttime to be between 6 p.m. and 6 a.m., or 18 hours and 6 in the morning. And then we're expecting to get nighttime. Let's run again. Oh, now it says, okay, well, I was expecting nighttime, I got daylight. Because daylight was hard-coded value, always get daylight, no matter what. Okay. So let me just now, I'm just doing this to illustrate to you, but he's not aware what's going on. So, Monsieur Claude, okay, let's see, what do you think about this? Aha. So now he's modifying existing file, the utility, the function. And what is he doing here? Aha. Okay, made it pass. Smart cookie. What did he do? He realized that we have hidden input, meaning, if we were to use the system clock, it would, any time of day, only one test would pass. It would be either night or day. But if we are going to explicitly pass in the hour, in this case for the day, 12 o'clock, and for the night, 22 o'clock, which is 10 p.m., then the test will pass. Okay, excellent. Now, at this point, when tests pass, and this is going to be contrived, of course, but I just want to, it's a demo, toy size problem. I am going to now, anytime I see the situation where all tests are green, I like to run mutation testing. I don't know if anyone here is, yeah. So I think in Java there's a phenomenal tool called PyTest, and I'm using Striker here. There's many of these tools. Just because we have all tests passing, it doesn't mean that the solution is solid. So I ran the mutation testing, and lo and behold, it created 3 surviving mutants. And I'm now going to complain to Monsieur Claude. So let me just... And let me copy again the mutants. Oops, what am I doing? Copy mutants, and then slow down. Okay, so without further ado, he just added some tests. Let's see what magic he did this time. Now, for those of you who do not know much about mutation testing, it's actually testing the quality. Oh, pass. Okay, bravo. Now, maybe to you this is not, but when I'm doing workshops and teaching, and I like to do mob programming. It's a beautiful discipline. I have the team in the room, and we're doing mob programming, everything working, and then I run mutation testing, and it creates mutants. The teams are often struggling to kill those mutants. But it's a good challenge, and they enjoy it. But this guy does it like it's nothing. Is this making sense? Am I going too fast for you? Tell me if you need me to slow down. All right, let's move on. I'm going to add a new test. And this test, it says, now I'm growing the solution. The first part was like, just need automation to tell me, is it daylight or nighttime? Okay, we got that sorted. I'm now going to use that very primitive bare bones functionality to control the lights on and off in the house. So I'm describing light control based on time of day. And I didn't say anything to Claude. And this test says it should turn the lights off when it's daytime. And the expected state would be lights off. And the actual state would send a message to control lights and then compare and see if the test passes or not. So let me talk to Claude. And sorry, I forgot to run this. Anytime we add a new test, I like to run. Oh, fails because it says, I don't know what this control light is. Okay, failure. Claude immediately is smart puppy. He says, oh, actually, I need the new function. I'm going to call it light control. And I'm going to follow his instructions and create it here. And I'm going to copy. And what is he saying for the tests? He wants to control light control. Test, okay, fine, cool. Makes sense, he's compartmentalizing. And this it? Yes. Sorry? We did not require this new file. Good point. I'm a bit messy when I'm doing... we did. So why is it failing? Control lights. So that test should be in a different file. Yeah. My bad. Sorry. Apologies. In the light control test. Okay. Okay, everything passes. Thank you very much for your help. It's always nerves when you're doing demos. Let's try another test here. Cool. He's thinking of everything. He's in a good mood today. All right, let's move on to the next failing test, which is... I'm now throwing a curveball, introducing a new challenge, which is, well, you know, depending on the time of year, the daylight and nighttime changes. So I'm saying, look, if it's summer, then you should turn the lights off in the summer when it's daytime, early in the morning, 5 a.m. So let's see how this works. Okay, it fails, so I'm going to give him the test. He's modifying the light control. Let me add the modification. And light control test. Okay, excellent, passes. Let's just try another one just to see if it... And I'm also nighttime in the summertime. Okay, let's see if that passes. Okie doke. I know I'm going fast, but we don't have much time. Usually in the workshops, we'll be doing slow and steady and discussing things. Let's add the next text. Fails in winter time. Okay. Again, Claude is modifying the function and leaving the test as they are. Controller function. Okay, it passes now. Let me just try this test. Excellent. Oh. All right, new failing test. Okay, so now I've introduced a new part of the system, which I call summer or winter, so that we can know whether currently we are in a summer or winter time. And give it to Claude. He's smart enough to read through this. It's just one test, and he realizes he needs to create a new function, season utility.js. And I'm going to just paste here. He's just hard-coding winter. And season utility test is a new test file. Okay, cool. Keeping things segregated. Should return winter or summer. So I guess this test here, season utility test, winter, and yeah, we don't need this one here. It found a new home. Excellent. I think we're close to the finishing line. Let's try this test. Oh, sorry, not here, but fails. Okay. Modifying the function. Adding conditional logic. Modifying season utility. Test. See, this is how I work. I just kind of rely mostly, my radar is on running tests. And if they pass, I'm kind of cool. Where we are at this point. Okay, so let me quickly, if you don't mind, run mutation testing again. Because at this point we have what I wanted to demonstrate, the toy-sized, distinguish seasons, distinguish time of day, also when to turn lights on or off. These are all functionalities that live inside the core competence layer. They're not aware of any IoT or any sensor, light sensor, or anything like that. You just like pass in some value in, and the functions will map or transform values and bring them back. Okay, so plenty of mutants. We don't have time, but if I gave him these mutants, he will kill them all, right? And then I would feel cool and safe. But in the interest of time, I will not do it today, but we can do it later. So key takeaways from this is, when I'm doing this TDD, then I get to the point where I spend my whole career learning how to refactor, focusing on clean code, Robert Martin, Uncle Bob, and all these great luminaries, people who thought leaders in software, Kent Beck, etc. Oh, another guy I want to mention is Alistair Cockburn, the guy who invented hexagonal architecture, which I think is a huge breakthrough. Anyone heard of hexagonal? Yeah. Great stuff. But now, when I'm working with Claude and these agents, I'm less and less, you've noticed probably, I'm not even checking what code they wrote. So long as they pass test, I'm like, okay, whatever. And also make sure that the next test will pass, right? But it's more and more this test-driven navigation gearing towards discovering the domain details. In this case, this is a very primitive, crude situation, but we kind of, step by step, starting from harsh conditions where we don't have any functionality, and we just have a test, poor test, fails, flat on its face, little by little adding a little bit functionality, growing the system step by step, from desert into like little grass and shrubs, and eventually get to the lush forest. And once we're in a lush forest, then everything changes, and then how we work changes as well. But lush forest is a domain, right? And oftentimes, like I said, we don't have crystal ball. We cannot daydream and envision that domain unless we start working. And sometimes I feel that I cannot understand the problem until I try the solution. I may think I understand the problem, but then when I try the solution, I'm like, oh, actually, I completely misunderstood. But the solution, which in this case are tests, is guiding my discovery, and it's a journey, and I am not assuming much, nor am I ascribing much of the system, but I'm open to learning from the feedback from these tests, where things are, where is the duplication, etc. And I'm less and less asking, what should the system do? And more, what rules already exist that this part of reality that we are trying to automate, and not aware of those rules. And there are some rules that we discover as we start working. So TDN, or test-driven navigation, I would say is domain archaeology. We are like archaeologists, we are excavating, we are unearthing some details that, regarding that domain, were unknown or unknown to us. And sometimes we don't have access to the domain experts, subject experts. So we use our tools. And I find tests to be the best excavation tool. They just kind of keep probing and poking and inform my thinking or the thinking of my team. And we see that using, in my opinion, sometimes people feel like, oh, using AI now, you can completely diminish the craft. Where is the creativity? Where is the innovation? But I think it's a refinement. It's a next step, possibly. I mean, it's too early to say, of course. We don't know. But I'm hoping that we will be moving from down in the weeds, too much focus on infrastructure and creating a lot of accidental complexity, and away from that into more becoming a valuable partner for the business in coming up with crisp and solid, safe, secure, performant, habitable, easily maintainable, easy to enhance automation or a system. Sometimes people say, well, software should be easy to change. Software is always easy to change, but it's not easy to improve. I can go in and I can make all kinds of changes, rename variables, blah, blah. It's a change, but didn't improve anything. Maybe even made it worse. But to make the change that's going to improve is a tough call. So I think we're maybe making the shift from implementation to more specification. And now we become real partners with the business. As software engineers, we can just go into the lab room and leave us alone, just give me the Jira ticket and I'm going to bang, bang, bang. I think that's less and less of a value proposition. It used to be, and we used to be very admired for that and lavishly rewarded. But somehow, I don't know, I feel like it's less and less of a selling point, and we are more and more expected to lean more towards the business, the end users, and understanding the domain, making our systems habitable. In the architecture, the classical architecture, which I think started in the ancient Rome by Vitruvius, he had postulated three principles of architecture. Utilitas, what's the second one? It escapes me. But in English, it has firmitas, utilitas, venustras. Firmitas means firm, means solid. Architecture must be solid. Utilitas must have utility. It's useful to us. Venustras, beauty, habitable, feel good as a human. The principle of least astonishment. The good products, even if I haven't read the manual, I haven't had any training, I intuitively feel like if I do this, this is going to happen. And if it does, then it's what we call the principle of least astonishment. But if I do something and something completely different happens, I'm astonished, and that's not a good user experience. And that's not the product that's going to succeed. So that's what I have for today. Thank you very much for patiently listening. Any questions from the audience?
You need to wrap up.
Wrap up. Okay, thank you.